Good morning, students and viewers. Thanks for joining me today. I am moving on in my algebra unit, and today we're going to talk about slope-intercept form, otherwise known as Y-intercept form, and going to talk about how that's related to what we worked on yesterday, which was linear equations. So first off, a little review. Linear equations are equations that show a relationship between two variables. All right, and in my last set of videos, we talked about how they're different from just single variable equations, in that linear equations show a relationship between two variables, and so therefore you're not solving for a number. You are using that relationship to a lot of times graph. And linear equations always result in a straight line when they're graphed, okay? And so we looked at function tables and how we can come up with some examples that show that relationship, and when we lay them out on a coordinate grid, they create a straight line, all right? And that line represents the relationship. So today we're gonna build off of that because we're still talking about linear equations. But we're talking about how to write a linear equation in a certain way that makes graphing really easy, and even a way to mentally see the line just by seeing the equation without having a graph to look at. Okay, so first off, what would I define slope-intercept form as? And first off, this is what it is. Y equals mx plus b. So just get used to hearing that. And what it is it's a way of writing a linear equation that makes the slope and the y-intercept obvious. Okay, so we're gonna a big chunk of today's video is really going to be just doing some work with slope-intercept form. In fact, after today's videos, you could go back to yesterday's worksheets and probably do those much easier. Because when you write a linear equation in slope-intercept form, there's no need to make a function table in order to come up with examples, because the slope-intercept form gives you all the information you need to graph a line. Okay, so let's look at the actual template for slope-intercept form. Slope-intercept form is known as y equals mx plus b. Okay, now what I want you to first realize is that in this equation, y and x are the same thing they were yesterday. Okay, those are the variables, they change. The other two parts of the equation, the m and the b, are really the numbers that you're going to see in the equation. Okay, and so those are the parts that we need to recognize when we see it and remember what they are. Something else I want you to think back to, earlier in the week we talked about slope, and when you do not have a graph to look at and you're asked to find slope, you need to go to the formula sheet and find that formula, y2 minus y1 over x2 minus x1, and plug them in that way, okay, if you remember. But if you also remember back from that video, I said on the formula sheet it says m equals, and I told you then that m is kind of the universal variable that we use for slope. Okay, m is the slope, and the slope is going to be attached to the x in the slope-intercept form. Okay, so the number that's attached to the x is the slope of the line. If you remember back what slope is, slope describes a line. It describes where it's going, and it describes the rate at which it's going there, okay, how fast it's going. So positive, it's increasing; negative, it's decreasing from left to right. Zero slope, no slope, if that's not there at all, then it's just a constant line moving from left to right, zero slope, okay? So in the slope-intercept form, the m, the number that's attached to the x is the slope, the rise over run, okay? The b, at least here when we first learn this, I say, think about the b as the beginning. Technically what the b stands for is the y-intercept. So if you remember what y-intercept is, when you're thinking about a line on a graph, a line crosses the y at the y-intercept, okay? So just a quick visual. If this is my coordinate grid and this is my line, the y-intercept would be this point, the point that the line crosses the y. Okay, so all you need to know about a line in order to write an equation, which is what the next videos are going to be about tomorrow, is the slope and the y-intercept. Okay, but today what we're going to work on is starting with an equation written in slope-intercept form, recognizing what the slope is and the y-intercept is, and then using that information to go straight to the graph and skipping the function table completely. Okay, so let's look at some examples. I'm sending you a few different worksheets today. You have two that look kind of like this. They're very similar. I'll show you this one and then this one. And what you're starting with here is first start with the equation, which you can see here. Okay, y is equal to negative 1/3 x plus 1. And what we need to do is first recognize that is in slope-intercept form. It's y equals a number next to the x plus or minus, and in this case it's plus 1. And so we have all the information we need. Starting with the slope, the m, the slope is attached to the x. So in this case, the slope would be a negative 1/3. You would write that here. The y-intercept is always kind of hanging out here at the end, plus or minus, or it could be not there at all, which in case would be 0. But remember, this number represents the y-intercept when we're talking about slope-intercept form. So the y-intercept is 1, all right? So you're going to start by writing these things down here and then come to your graph. Now, when it comes to a graph, you want to start with the y-intercept and then follow the slope, okay? So I'm going to come back to my big screen here and give you an example, okay? So give me just a second here. All right, I'm back. So I made a coordinate grid and wrote down the problem that we're working on, okay? So the equation that we're working on is y is equal to negative 1/3 x plus 1. And what I need to do is, first recognize it is already in slope-intercept form, okay? And then I need to identify the parts. So the slope, the m, is attached to the x, which in this case is negative 1/3. The plus b, the b is the y-intercept. It's really where we're going to begin, begin when we graph, okay? So the y-intercept is a positive 1. So now I need to go to my graph. When I go to graph from y-intercept form, I begin with my y-intercept. What I know is the line crosses there. The line crosses at the y1. So here's the x, here's the y. I need to go to the y1 and make a point because I know that the line is there. From there, I follow my slope, okay? So the slope is negative 1/3. Think about what a negative slope means. Okay, a negative slope means the line is dropping, decreasing from left to right. So I need to keep that in mind when I'm putting this on here. It's got to go down. Okay. Now the rate at which it goes down is my numbers, 1 over 3. So I'm going to go down 1 over 3, rise, run, rise, run. Down 1 over 3, down 1 over 3. When you go over 3, that's where you make it positive or negative. Okay. So I'm going down 1 over 3. Since I go this way, it's going to make the line go down. If I made a mistake and went down 1 and over 3 this way, it would make a line that is increasing, which would not be correct. Okay, so the y-intercept, follow the slope, down 1 over 3. If I want to make sure I get a good line, I could go ahead and do it a couple times. Down 1 over 3. Something like that. And there's my line. Okay, we really only need 2 things to graph a line. We need to know where it's going and how fast it's going there. And then we need to know where in the coordinate it is. Okay, in this case, it's crossing at the y1. That's what this does, is it locates where in the graph that line falls. Okay, the slope tells where it's going and how fast it's going there. So y-intercept form, slope is the m, y-intercept is the b. Let's go back and look at the next problem. Okay, if we want to check our answers, go to the second page. Notice the line. Crosses at 1, it's dropping 1, going over 3 to make a negative line. All right,